So today we're going to be talking about the Pre-Calculus Edgenuity Section 7.3 entitled Modeling with Matrices. The objective for this section is to model and solve real-world problems using matrices. So let's look. This is all going to be word problems. So let's take a look at our first word problem. Company makes and sells widgets and gizmos. Companies in these theoretical problems often make widgets and gizmos. In January, they sold 350 items for a total of $9,000. The widgets sell for $35. The gizmos sell for $22. How many of each did the company sell? And for purposes of staying true to what you're going to see in the lesson, we're going to let widgets equal x sub 1 and gizmos equal x sub 2. If you were writing it on your own, you might let widgets equal w and gizmos equal g, but that's not how they present it. So I'm going to stay consistent with the way that Edgenuity presents it. So in order to do this, one of the first things that we have to do is just write down the system of equations that tell us stuff, okay? So the first thing we know is that if we put widgets and gizmos together for the month of January, we sell 350 of them, okay? So widgets are x1, so that's the amount of widgets, plus the amount of gizmos. Gizmos are x2. And when we add how many we sold together, we get 350 total items that we sold. Okay? So then it tells us how much we sell each one for and the total amount of money that we got from selling them. So each widget is $35. So we'd take $35 times the amount of widgets. Plus each gizmo is $22, so 22 times the amount of gizmos. And that would give us a total amount, which is $9,000. Okay? And so then what we want to do is we want to be able to write each of those, or write this whole thing in matrix form, because we've been talking about matrices. These last two units have been about matrices. So let's see how we would turn that into a matrix. Let's see how we might turn it into different types of matrices, okay? One of the things it will ask you to do is to write it in a form like this, where the typical form, that is to say, is to have your matrix A, which is just the coefficients from these terms, that is the numbers attached to the variables, and that's your matrix A. And then to have your variable matrix, which is your matrix B, and have that equal your answer matrix, which is your matrix C. So that's one way of writing it. And then we have the so-called modified matrix, which is another way of writing this, and I'm going to have to go back and look at my numbers as I do this, so forgive me, please. 1, 1, 3, 5, 22. 1, 1, 35, 22. And then you put that little bar there, and then you put the answers, which are 350 and 9,000. 350 and 9,000. And this is the modified matrix. And this comes from doing row operations. We're not going to worry about row operations, so but I did want to show you that because it asks for that over and over in this section. But the one that we're going to worry about is matrix A. And that matrix C or that matrix B, depending on how you write it. Sometimes this is, in fact, a lot of times, instead of this being B, this one is matrix X, and this one is matrix B. So just something to take note of. A lot of times they're written that way. So if I take matrix A and I take matrix B, there's a lot of things that I can do with these. You might recall that A inverse times B equals X. You can go back to a previous lesson to see how that sets up, but algebraically that sets up. We could also use Cramer's rule, which we learned in the first section, and then we have to set up more matrices, an A sub X, which replaces the X column with the answer column, and then copies the second column, and that's our A sub X. And then A sub Y, which copies our first column and replaces our second column with our answer column. And that's our A sub Y. And the other way of doing this is to take the determinant of A sub X over the determinant of A, and that will equal x1. Oh, maybe I should have, for purposes of this one, maybe I should label it differently. A sub x1 and A sub x2, since we have, instead we have an x1 column and an x2 column instead of an x and a y column. So the determinant of A sub x1 over the determinant of A will give you x sub 1, and then x sub 2 will be the determinant of A sub x2 over the determinant of A. And you've seen how to do these different things with the technology available and with various paper methods. So what I'm not going to do is go through and give the answer. I think that the setup should be enough for you. All right, I will pause and let you look at this and see if there are questions. Okay, there being no questions, I'll move on to our next problem. Our next problem, we're going to give you several tables and give you a problem. So it says a farm's 3 stock fertilizers are shown in the table. That's this table here, because that's the stock mixtures. How many pounds of each nutrient? So we've got our nutrients right here and our different mixtures there, there, and there. To make a mixture that has 50% nitrogen, 30% potassium, and 20% phosphorus. And we want to make 100 pounds of that, as you can see here. So one thing you might note is that we want 50 pounds of this, that's 50% of 100, and 30 pounds of this, that's 30% of 100, and 20 pounds of this, that's 20% of 100. So how do you set this up? Well, you say, okay, I've got these here that tell me a bunch of things. And I could say something like 0.8A plus 0.4B plus 0.2C, and that equals the nitrogen mix. And I want the nitrogen to come out to 50 pounds. Okay, so that gives me that. And then for the potassium, 0.1A plus 0.4B plus 0.2C equals 30 pounds for the potassium. And then for the phosphorus, 0.1A plus 0.2B plus 0.6C, and that'll equal 20 pounds. And what I can do with that, let's go over, I can make a matrix A out of that, and that'll be 0.8, 0.4, and 0.2. 0.8, 0.4, 0.2, and 0.1, 0.4, and 0.2, 0.1, 0.4, and 0.2, and 0.1, 0.2, and 0.6, 0.1, 0.2, and 0.6, and there's my matrix A. My matrix X, I think in the lesson they again call this one X1, X2, X3. So instead of A, B, and C, we're using X1, X2, and X3 for our X matrix. And then our B matrix is 50, 30, and 20 in one column. 50, 30, and 20 in one column. That's our matrix B. And again, different techniques. You could do A inverse times B equals X, or you could make matrices A sub X1, which would be replace the X1 column with the answer column and copy the other two columns. You could make your A sub X2 matrix, which would be replacing the X2 column, so copy the first column, replace the second column, and copy the third column. And make your matrix A sub x3, which would be copy the first two columns. And copy the answer column for the third column. And then you could use Kramer's rule here, which would say that x sub 1 would be the determinant of A sub x sub 1 over the determinant of A, and x sub 2 similarly determinant of AX2 over determinant of A, and x sub 3 determinant of AX sub 3 over determinant of A. Or you could use this. Either way, you're going to need technology for all of this. And again, I'm not going to take you through the technology. I've done that on a different section. So I trust that you can either look back at that or that you can re-find it for yourself. Let's look at another one. Solve a linear system representing cost per hour of 3 machines. Now this one's really straightforward, but it's an interesting problem, and I want to discuss it just for a moment. We've got 3 machines, our X1, our X2, and our X3 machine. And X1, X2, and X3 represent how much they cost per hour to run, and we're going to say each one of these equations represents a month. So we run this machine for 100 hours in that month, this machine for 130 hours, this machine for 16 hours in that month, and then we take the cost per hour of each, multiply them, and then you have per hour, so you have hours on the top here and on the bottom here. So you have 100, just to illustrate, 100 hours times X1 dollars per hour, and then your hours cancel, and you get just dollars, okay? So that's why the answers are all dollars. So these are all dollars. All right, and then you set up matrix A the same way. 100, 130, 16, 120, 180, 28, 160, 190, and 10. And your matrix B, 3528, 4864, 4920. And then you can do A inverse times B, or you can make your AX1, AX2, and AX3 matrices and use Kramer's rule. So this, if they give you the system, this is even more straightforward. And again, one of the things they're going to ask for is the modified matrix, which instead looks like the two matrices sort of put together with a little bar between these parts and the answers. So it looks like this. And they're going to ask you for this, so that's why I'm showing you again. And again, this is for purposes of You set it up this way to do row operations, but if you've gone through 7.2 yet, you know that row operations are really tedious. That is, they take a long time and they're not very efficient. They can be a lot of fun. I have a lot of fun doing row operations, but they take a lot of time. If you find yourself, my advice to you is that if you find yourself enjoying the process of doing row operations, like in 7.2, you might be that much closer to being a math major. One last problem, which is a tiny bit different than the other ones, and I noticed problems like it on the quiz sections, so I thought this would be good to go over. Let us suppose that you order DoorDash. You're going to order 4 burgers and 3 fries for some friends. Then for yourself, you order 2 burgers and 2 fries. And I don't know where this is from, but it's from restaurant R, whatever that is. And on your friends, you spend $25. On yourself, you spend $15. Let's just say that you order them, like you order for your friends, and it's on its way, and then you're like, oh, but wait, I want some for me too. And let's say you've got some promotion where they tell you, oh no, you're not going to tip this time, there's no delivery fee this time, this is some promotional deal, so you're only going to pay for the food itself. All right? So, so in the first one, if you wanted to figure this out, you might say, okay, that's 4 burgers. That is 4 times the price of the burgers, plus 3 times the price of the fries. And when I add all that up, I'm going to get $25. And then for yourself, you ordered 2 burgers and 2 fries, and that costs you $15. And then you can see that we're setting up another system of matrices here, 4, 3, 2, 2 as our A, and then our matrix X would be B and F. That would be our matrix X, and it would equal our matrix B, which would be 25 and 15, and that would be B, and then you can do A inverse times B, or you can do Cramer's rule. All right, well, that is all I have for you guys today. Are there questions on this last part? Okay, with that being done, I will end today's